Hi everyone. First of all, I'd like to thanks to BioCreative organizers for this wonderful event. Today, I'm going to discuss our participation in DrugProt Task. As we all know, DrugProt Task is all about automatically detecting the relations between chemical compounds and genes in PubMed abstracts. We hypothesize that an ensemble system can achieve superior performance if there is enough divergence among the models. Our objective is to achieve divergence among BERT-based models. We propose an ensemble system including multiple BERT-based language models. We explore various architectures and pre-trained models for our goal. We considered three pre-trained models, namely BioBERT, PubMed-BERT, and BioM-Electra-Large. These models have different masking, vocabulary, and learning objective techniques. We include BioM Electra-Large to study the effectiveness of the large model. We also investigated different model architectures to summarize the information in the last layer of a BERT model. We consider the last layer of the CLS token, an LSTM layer, and an attention layer at the top level. Another dimension we investigated is the class-weighted loss function to mitigate the class imbalance in the DrugProt corpus. Finally, we consider two different entity masking schemes to create diversity in the data representation. We were provided with a set of abstracts, entities, and relations. We first split the raw text into sentences, and we discovered that all relations in the DrugProt corpus were enclosed in one sentence. Therefore, our system considers interactions occurring only within a sentence. Then we create sentence instances where each instance is marked with a protein and a chemical mention. We assign this instance to one of 13 relation types or marked as negative if no relationship exists between the entities. Then we apply the entity masking in two different ways. On the left side, we anonymize the target entities using predefined tags. And on the right side, we directly insert the start and end entity markers. Then we feed these instance relation pairs into a BERT variation. Overall, we addressed the relation extraction problem as a multi-class classification problem. We considered two ensemble learning methods. We first consider an MLP as a meta-learner. Specifically, we extract the last layer of CLS token from each fine-tuned model. We have 5 different models here. Then we combine the model predictions using the MLP. Secondly, we consider majority voting, which select relation type that gets the most votes out of 5 individual models. I would like to describe the overall training process. We submitted 5 runs for the round 1 and 2. We used the 5 individual models in group A and B, respectively. We used the original training set to train the individual models and used the development set to train ensemble models. As a ensemble system, we use MLP to combine the output of individual models. For round 3, we use the models in group B, but this time we combine the training set and development set and created 5 partition as you see at the left corner. We use 70% of this data to train individual models. Therefore, we obtain a group of 5 models corresponding to each partition. We train the separate MLP for each group, and after that, we use majority voting to combine the output of MLPs. For round 4, we have the same partitioning, but this time we use a single model instead of 5 models. Therefore, we didn't need MLP. We use majority voting to combine the output coming from each partition. For round 5, we again use the single model, but we train it with all the data we have. Results from the test set demonstrates that we have the best F1 performance in round 3 and round 4. And interestingly, the F1 score of the single large model, as you see in the row 5, is almost the same as those of the ensembles of rounds 1 and round 2. And we observed that the best F1 scores of rounds 3 and round 4 are due to the increase of precision, even if the recall dropped slightly. Finally, the results on the individual relation types shows that we obtain the best performance in F1 for the antagonist and inhibitor relations. We also observed that rounds 3 and 4 have a uniform increase in F1 performance for almost all relation types. Thank you very much.